So please write.
Okay, sir.
Sampling distribution. This is the only part that we left in part 3. In part 3, we had 3 things: central limit theorem. Second one was confidence interval. And now the third one, sampling distribution. And till now, there is no question paper, like what you call, without this question. So please write like this. It is kind of like an experiment, like what you call, which they ask as a regular question, So please write like this. Consider a population Do you remember the word population? Population means we include all the data items. But this is a small experiment, so they have kept only a few data items. So please write, consider a population 2, 4, 6, 8. Consider a population 2, 4, 6, 8. The first question. Find the population mean, population standard deviation, and population variance. Are all of you able to hear me? Is there anyone who cannot hear me properly? If someone is there, please raise hands, or like Sumit, are you able to hear me clearly? Suman?
Yes, sir.
Jessica?
Yes, sir.
Yes, sir, I can hear you.
Last day you skipped the class. Again, you made it 75%.
Yeah, sir, I had a family function I had to attend. So.
Yeah, no problem, but please use the videos or somehow study. And if you're not comfortable, please ask.
Okay, sir.
Now the second question. Write all possible samples. Write all possible samples of size 2 without replacement. By the way, you might not have heard the word replacement. The simple word is repetition. I'll repeat, I'll ask the same type questions in this assessment. That means this coming Friday, you'll see the same type question. The numbers may be different. Maybe it'll be like 3, 5, 6, something else. And once more, I'll repeat, the same question will come in the final exam also. Till now, I have never seen a question paper without this. The third question. Find the sampling distribution of sample mean. The fourth question. Prove that the mean of the sampling distribution is an unbiased estimator of population mean. Also find the standard error. We'll do 3 questions like this type, and I'll repeat once more. Study today itself. This Friday in assessment exam, the same type will be there. And again, after 1 month in the final exam also, you'll see the same type of question. Okay, now look at this. This is a very interesting example. It's a very interesting example for people who love statistics, and a matter of 5 marks for students who want to score marks. Okay, now the first part I don't have to teach you because you already know how to calculate mean and variance from calculator. So take your calculator, please. All of you take your calculator. So can you tell me what are the members of the population, Suman? Who all are in the population?
2, 4, 6, 8.
Yeah, it is a shame to call it a population because normally when we think about population, there will be like what you call 1,000 items, 10,000 items, etc., etc. But still, the definition of population is collection of all the members in an experiment. But I told you this is an experiment, and for those who love statistics, this is a very interesting experiment. And those who do not love statistics but you're studying merely for engineering degree, it's worth 5 marks. Anyway, it's something worth for you. So take your calculator, put it into one variable mode, and I want you to plug in the values 2, 4, 6, 8, and calculate population mean, population standard deviation, population variance. Others also please keep videos on. Rael, Pravesh, keep videos on, please. Especially Rael, otherwise you'll feel like touching that mobile, watching it. But Rael's camera is in the best, like what you call, position for studying. Today you look what you call less tired. Last Friday it was like what you call, I was also tired, and I can feel most of you were like tired. Okay, come on, tell me please, one by one, tell me the answers. What is the population? Do you still remember? Please take a calculator. Take a calculator, please. Today Nitish didn't come.
I am there, sir.
Oh, your video is off. Keep it on, Nitish.
I will turn it on now. Sure.
Please take your calculator and plug in, put it in one variable mode. Nishal, do you have a calculator? Please put it in one variable mode. And if your mic is not working, Nishal, type all the answers in the chat. Population mean, population standard deviation, population variance. Yeah, tell me please, what are the answers once more? What does the population mean?
5.
I hope all of you remember the notation. Population mean is mu. What's the value? Come on. Others also answer, please. It's not only Nishal.
5.
5.
Yeah. Next, what is population standard deviation?
2.5822.
No.
Is Nishal's answers correct?
Yes, sir.
2.236.
2.236, sir. This is for population.
Come on, I asked for population. I didn't say
2.23.
sample.
2.23.
2.24.
Is 2.58 sample mean or?
That is sample mean.
Oh, I'm sorry about that. And what about population variance?
4.99.
Okay, now can you please read the second part? Can you please read the second part? Those who attended the class last week will remember I talked about two practical methods of sample collection. One is called stratified sampling and another is called cluster sampling. In stratified sampling, we will divide the entire population into many parts, and each part will be called strata. And then I told you, what do you call, the person who is collecting data will go into each strata and collect information, and they will report the arithmetic mean. Do you remember? And finally, I told you the set of all the arithmetic means will always become normal distribution, and that is called central limit theorem. In cluster sampling also we learned something similar, but instead of like what you call someone dividing the population into group, we look for natural clusters like what you call marketplace, shopping malls, colleges, canteens, hotels, etc., and we will collect data from each place, and from every place someone will report the arithmetic mean. And according to central limit theorem, that will follow what we call a normal distribution. Do you remember this? Come on, respond, please.
Yes, sir.
Yeah. Okay. Anyway, can you please read question the second part? Sumit, can you read the second part? What did they ask you to write?
Write all the possible sample of size 2 without replacement.
Yeah. So tell me, what is a given population? I told you long back itself, it
2, 4,
looks
6,
critical.
8.
It's a shame to call it a population because the numbers are only 4 numbers. But experiment point of view, what's the population? 2, 4, 6, 8.
2, 4, 6, and 8.
Yeah. So can you tell me population size? What is the population size?
It is 2.
No, population size,
Oh, 4.
Now, next one, required sample size.
2.
Is it with replacement or without replacement?
Without replacement.
Means without repetition. You are not allowed to take the same data again and again. Okay, now I'm going to use something from your like what you call class 11, permutation and combination. So I'm going to write like this. Possible number of samples is equal to capital N, C small n is equal to 4C2. That will be, can you take the calculator and tell me? So tell me how many different samples can we take? Asmit?
6.
Yeah, 6.
6, sir.
6.
Okay, now please write like this. Possible samples. So how many possible samples are you expecting? Come on, answer please. How many possible? Yeah.
6.
So let's start, let's do it systematically. So one possible, look at this, someone will go for collecting data collection, and from how many people will they collect data? From how many people will they collect the information? Only from 2 people. So one possible data information they will bring is 2, 4. Someone else will collect in a different manner. They might get the information 2, 6. Someone else might get the information 2, 8. Now, someone else might get the information 4, 6 or 4, 8. Or another possibility, someone might get the information 6, 8. Did you understand? When we go for cluster sampling or when we go for stratified sampling, these are the different possible data people will be able to collect. But practically, it won't be like this. Practically, population means it will be in billions and millions. Here, how many members are in the population? Tell me. Just
4.
4.
Yeah. And think about how many different possibilities are there.
6.
6.
Yeah. So see, different people will bring different information as samples.
Yes.
Okay. Now, once more, I'll repeat for those who did not come last week. Practically, we have 2 methods of data collection. One is called stratified sampling and the other is called cluster sampling. In stratified sampling, what we do is we divide the population into many parts as much as we can. And from every strata, for example, just imagine we divide Kathmandu into 100 parts. And from every part, we will collect information. Maybe the income of a person, maybe the height of a person, maybe how many people are happy with the government. Any information, we'll collect some information. So similarly, how many members are in this population? Tell me, how many members are in the population?
4.
And like what you call, we are collecting all possible data of size 2. Okay, anyway, please write like this: representative sample mean. I don't know how many of you listened last week, but do you remember I told you, like what you call, the person who collects data will not inform the data, but they will give you the arithmetic mean. Do you remember that? So can you tell me the person who, what will this person report? The person who collected the information 2, 4, what will be the report? Yeah, what is arithmetic mean, Sushmita?
3.
Add them, divide by 2. Come on.
3.
Next.
4.
Next.
5.
Next.
5.
Next.
6.
Next.
7.
7.
Okay, once more, I want you to read the questions one by one. We are doing a small experiment. And how many members are in the population?
4.
Only 4 elements. Now, we found population mean, population standard deviation, population variance, and many students made mistake here. Please be careful in the exam.
Yes, sir.
Now, what we did is we are writing all possible samples of size 2. We are writing all possible samples of size 2 without replacement. Now, what is the third question? Can someone read? Subhash, what's the third thing that we have to find? Come on, please read the third part.
Distribution of sampling mean, a sample mean.
Yeah. Okay, now we are going to write the sampling distribution. Okay, so start like this.
So what if there was with replacement?
With replacement means that will be a huge number. It will be like what you call 2 to the power 4. 16 possibilities are there. If it is without replacement, NCN. If it is with replacement, N power N. I'm sorry, that will be 4 to the power 2. Anyway, it's 16. It will be like what you call 2, 2, 2, 4, 2, 6, 2, 8, 4, 4. So many things will come. 4, 2, 4, you got the point, right? So normally they will never ask that. Normally.
Okay, sir.
Okay, now please write. Let capital X bar be the discrete random variable associated with sample mean. So we are going to convert the situation into a probability distribution. So what is capital X bar, Pravesh? What did I assume capital X bar to be?
Discrete random variable associated with sample mean.
Okay, Pravesh, can you tell me all possible values of sample mean? Just now someone told me all possible values without repetition in ascending order. One possibility is someone might report the answer 3. Someone might report the answer 4, 5, 6, 7. So what I did is I'm writing all possible sample means. Now, can anyone tell me what is the probability that we will get 3? Come on. In the beginning itself, you know that there are only 6 possible cases.
1 by
And
6.
how many times did 3 repeat?
1 by 6.
Yeah, very good. 1 by 6, 1 by 6, 2 by 6, 1 by 6, 1 by 6. Now look at this. This is called sampling distribution. If you love statistics, try to understand. And once more, I'll repeat, those who do not love statistics, this will come in exam, so somehow manage to study the technique. Asmit, what do you call this? Sampling distribution of sample mean. Now, can you read the last part? What did they ask? What did they ask you to find?
Mean of sampling distribution.
Come on. I think you still remember the formula sigma pixie. I think most of you still remember the formula, that pixie formula, sigma pi xi. So please write. Mean. What is another word for mean?
Average.
Expectation.
Yeah, please write mean of sampling distribution. Mu x bar. What is the formula? Suman, sigma.
I need
Please
to
find it. Sushmita, do you still remember this? Subhash, do you remember this?
random variable
Yes, sir.
distribution function.
Come on. Someone tell me the value, please.
One by 6 times 2.
5.
Now, can you please look at the question, Pradeep? What did they ask you to prove? Mean of the sampling distribution is the same as?
Proof, sir. We get the same mean.
Did you get the same thing from population mean?
Yes,
sir.
And actually, for people who love statistics, this is a very good news. What you just learned is, using sample, we are able to predict the population. How did you get the value 5 now? How did you get the value 5? From samples, right? Sumit, are you able to understand?
Yes, sir.
We got 1 by 6 into 3 plus 1 by 6 into 4, whatever. When you finally find it, it will be 5. But the good news is, we found this value from samples. And that is a good news for statisticians, because we learned that using sample, we are able to predict the population. Even though it is theoretically, it is a good news. Are you able to understand?
Yes, sir.
Asmit, did you get the values?
Yes, sir.
5?
I got it.
Okay, now, let me ask random. Jessica, can you please tell me the formula for variance?
Sigma square.
Yeah, that I know, but what is the variance of sampling distribution? Come on. It's hardly 1 month before we learn. Sigma pixie square
Square
minus.
minus mean square.
Find it, please.
Five by two.
I don't know. Let's see. What's the value? Someone tell me. What is variance to answer?
5 by 2.
Five by three.
3.
I bet you.
3. 3.
5 by 3 will be. Yeah, Nishal,
1.667.
Nishal answer. 1.667. And what is standard deviation?
Under variation.
Yeah, how much?
1.29.
Yeah. Did all of you get this? So please write one word here. Standard error is equal to standard deviation of sampling distribution. In this innovation class, sir. So standard error equal to standard deviation of sampling distribution. And can one of you please, like what you call, find this value? Can one of you please find? Sigma you already found, right? Once upon a time. Sigma. How much? Sigma? Come on, turn on the mic and answer, please. In class, you all respond properly. And what is small n?
Small and 2.
One point 1.29.
How much?
No, sigma value is 4.99.
You might be talking about sigma squared. Sigma.
2.23.
Come on. Others also answer.
1.29, sir.
1.29.
Where did I see this 1.29?
Standard
We just
deviation.
find.
Oh, so look at this.
Sampling.
This is another method of finding the standard error. Did you get the point? This is another method of finding the standard error. Now, I know 2-3 of you are like really interested in this subject, and you have to be honest, because later when you go for masters, etc., you will need this Yeah. Okay, now look at this interesting part. From where did we get mu x bar? Mu x bar means the mean of the sampling distribution. So you have to understand that this mu x bar is from samples. From where did we get this value? By using, come on, answer.
Table.
No, from sample,
Sampling
from sample.
distribution.
Come on, where did he make this table from? From the samples, right? And isn't it matching with the population mean?
5.
And that is why it is called an unbiased estimator. What do you call in Nepali? What do you call just take it as something like that? You say right, same value.
Just tako testay.
Okay, please correct it, please, someone. Yeah. Now, but when you look at this standard deviation value, you'll be slightly disappointed because this value and this value are not matching, right? Are they same? No. Can you see 2.24 and 1.29? But statisticians have found that there is a connection between that value and what we found, and it is called standard error. Okay, anyway, we'll do one thing. Let's do 2 more problems like I promised. Before that, I wanted to show you something. Can you see the question paper?
Yes, sir.
Okay, so you can see that like what you call Bayes theorem. Anyway, I wanted to show you the question paper also. And once more, I'm repeating, like what you call later, near the exam, when you want to study statistics, please call me. We can put a class like this and we can discuss the question paper. I'll give you a clear idea what to study, etc., etc. But inform me 2-3 days before, that's all. Box plot this. Can you see a distribution? Poisson distribution, normal distribution. Okay, it'll be very nice if you can do question number 8. Let's do question number 8. Suman, can you click a picture and send the picture into the group?
Okay, sir.
Question number 8. Whether you understood the true statistical meaning or not, please make sure you're okay with the method. Because in the coming exam, that is all it matters. But if you can understand the true statistical meaning, it's like really, really good. Shall we start? So tell me, please, how many members are here?
5.
What is the population size?
5.
What is the notation for population size?
Capital N.
Capital N.
And what is the required sample size?
3.
What is the notation for sample size?
Small n.
And clearly it is mentioned without replacement. So can you tell me how many samples are possible?
10.
How did you get that, Sushmita?
Yes, sir.
Shall I go down or is it okay? Let's do it together. Please write possible samples. And here you write representative. I don't know how many of you read the question properly, but can you see? Calculate the mean of each sample. Can you see? Calculate the mean of each sample. That is why I'm writing the representative. Okay, now tell me the population. What are the members of the population, Sumit? 3, 6, 9, 12, 15, right, Sumit?
Yes, sir.
And how many samples should we take, Sushmita?
Sample.
No. How many should be there? What's the sample size?
10.
No. Sample size. Evta sample में कदी member होने परचा?
3.
3, sir.
Yeah, 3. So do it very systematically. The first one is 3, 6, 9. Again, let us start with 3 and 6. 3, 6, 12. 3, 6, 15. Now, let's start with 3 and 9. 3, 9, 12. 3, 9, 15. Now let us start with 3 and 12. 3, 12, 15. If you do not do it systematically, you will be lost. So please do it very systematically. So I have exhausted everything with 3. First I did 3 and 6, then 3 and 9, then 3 and 12, exhausted. Now I can forget about 3. Now start with 6 and 9. Come on, tell me. Someone tell me, please. Subhash, tell me. 6,
9, 12.
9,
next. 6, 9,
15.
next.
9, 12,
6, 12,
15.
So that's also done. Now let's start with 9. 9, 12, 15. Is that all? Anything left or did we do all? Count it, please.
Yes, sir, done.
Now tell me the sample mean one by one. In your assessment exam this Friday, please expect one question of this type. And also after 3-4 weeks, when you write the final exam, expect a question like this. As we are studying probability, we have to strongly believe in what you call past paper. Because probability itself is based on past, right? Predicting the future with past.
Sir, 6, 7, 8, 8, 9, 10, 9, 10, 11.
Slowly. 6,
7, 8, 8, 9, 10, 9, 10, 11, 12. Hello, my friend, check the answer. Hey.
Correct, Habibi.
Okay, now can you see? They are asking the same question. Verify that the sample mean is an unbiased estimate of the population mean. So, calculate the population mean. Even though it is not asked, can you calculate the population standard deviation also? Just for experiment's sake.
Open to 4, 5, 9, open to. Sir, mean 9.
Mean is 9.
4.24.
Is it root under 18 or something?
So direct using calculator. I use the calculator.
Yeah, I remember. 4.24. Come on, please write. Let X bar. Please write the sampling distribution. Write the sampling distribution. How do you write the sampling distribution? What is the first dialog? Let X bar be the discrete random variable associated with sample mean.
Sir, can we directly find the mean from the table?
No. Like what you call, you have to do it like this because normally they will ask the sampling distribution. What are the possible numbers? 6, 7. Can you tell me the probabilities one by one?
One by 10.
1 by 10, 1 by 10, 2 by 10, 2 by 10. Actually, can you see the normal distribution here? It is slowly increasing. It's a very simple. I told you, even to call 5 members as a population itself is something like what you call like what you call. Normally, population will be like so many members. Still, are able to see the frequency reflecting the normal distribution? It is kind of like 1, 1, 2, 2, 2, 1, 1. What's the formula for sampling? What is the formula for mean?
Summation
Sigma pixie.
Yes, sir.
sigma pixel.
And I'll guarantee the answer is
9.
because sampling mean is the unbiased estimate of the population mean. What do you mean by the word partiality in Nepali? Pakshapad or something like that? Partiality. Like showing partiality means like not complete. Kind of like saying unfair. What is unfair? Like what you call in Nepali? Like
Pakshapat.
Pakshapat, right? Yeah. So here, like what you call, What unbiased means, like what you call, it never shows any pakshapat, like what you call exact value. What you call sample mean and population ko mean are kind of like matching. Did you understand properly? If someone has a doubt, please ask now itself. Nidish, are you following?
Yes, sir.
Are you 100% sure you're following? Heyman, what about your Heyman?
100%.
Yes, I am following, sir. The Buddhi Data, sir.
Yeah, okay. Can you please look at the question paper? I'll show you again so that like what you call, you'll feel a little bit happy with this. Can you see? This is some other, I think this is 2078. Look at this. Can you see? Again, the same question coming. Are you able to see this question number 7?
Yes, sir.
Should we do or shall we, like what you call, go for the next type now?
We can go for next.
I'll again show you 2-3 question papers so that you're like what you call, a little bit more comfortable. Please look at question number 7. This
So
time,
what is SWR in that question?
I think without replacement.
Write down all possible samples of size 2 with SWR.
I don't know who found that such words. There is no abbreviation. I was just searching. There's no such word in statistics. I think someone might have thought like simply without replacement. I don't know. Some questions are really funny. Seriously, like what you call. And can you see what we learned like last week in college? Normal distribution. And last week, confidence interval.
Sir, sampling without replacement, sir.
Sampling without replacement. I thought so. I thought simply without replacement. But they should not use such abbreviations.
Yes, sir.
Yeah. I was going to say, like what you call bad news. Can you see? Once in a while, instead of asking a problem, what did they do? I'm warning you from the first day. Who is the most dangerous person in your exam? You can see, right? Theory part. But normally it is not like that. You can see another question paper. Here also theory only. Let's see what they ask for you, whether theory or problem. The another problem with your system is like what you call, they will ask like 2 teachers to 3 teachers to prepare a question paper, and they will cut the paper into 3 parts and set it. There will be one main person, and they will what you call take few questions from here and there and set it. Shall we go for the next one?
Yes, sir. Sure.
Sir, you are making paper or not, sir?
I don't know. Don't worry, whoever makes paper, the pattern will be same unless the person who edits at the last, what do you call, makes a mess.
But you check it, sir.
Yeah, don't worry, the what do you call, the pattern will be same. There won't be much difference. The only part, like what do you call, I'm always worried is sometimes they ask unnecessary theory. Sometimes